Good morning, students. Yesterday we have discussed about the escape speed. Escape speed is calculated to be 11.2 km per second. The minimum speed to be given to an object to be thrown in a vertical direction so that it can just escape from the gravitational field of the earth is called escape speed. And we discussed finally why there is no atmosphere on the surface of the moon. Moon doesn't have atmosphere. The main reason is the escape speed on the moon surface. The escape speed on the moon surface is 2.3 km per second. That we have calculated using the acceleration due to gravity on the moon surface, which is 1/6 of the acceleration due to gravity of that of the earth. That is 9.8 divided by 6. So naturally it is very less. 1/6 of that of the acceleration due to gravity on the surface of the earth is the acceleration due to gravity on the moon surface. And then radius of the moon is also very less. So when you substitute square root of 2 Grm for moon surface, we get the escape speed on the moon surface hardly 2.3 km per second. 2.3 km per second, which is almost 5 times less than the escape speed on the surface of the earth. Therefore, when the moon was just formed, the gases which were formed were having the speeds much greater than the escape speed on the surface of the moon. So the molecules could not be stuck to the gravity of the moon. So they escaped away from the gravitational field of the moon. This is the reason. The escape speed on the surface of the moon is very less, 2.3 km per second. This is how we discussed and concluded yesterday. Today we will solve an interesting problem. Interesting problem of sending a projectile from surface of a planet, let us say. There are two spheres, you can see here, two uniform solid spheres of equal radii. These are the two uniform solid spheres of equal radii. Both the radius are same, but one is having mass m. The first sphere is having mass m. The second sphere is having mass 4m, and they have center to center separation of 6r. 6r is the center to center separation distance, where r is the radius. Okay. The two spheres are held fixed. Assume that these two spheres are held fixed from their center to center distance, fixed. Right? A projectile of mass m is projected from the surface. A projectile of mass m is projected from the surface of the first sphere towards the second sphere. The projectile is projected from the surface of sphere of mass capital M, that is from the first sphere, directly towards the center of the second sphere. Towards the center of the second sphere, like this, straight. Obtain an expression for minimum speed v of the projectile so that it just reaches the surface of the second sphere. It just reaches the surface of the second sphere. So assume that these are two planets. One is having planet of mass m, another one is having of mass 4m. Interesting thing is that both are having same radius, and the distance between their centers is 6r. Okay. When these are two planets, think that they are held fixed, then there exists a mutual force of attraction, mutual gravitational force of attraction between these two planets. The second planet pulls the first planet towards its center. Similarly, the first planet pulls the second planet towards its center by gravitational attractive interaction. Then you are asked to send a projectile from the first sphere towards the second sphere. What must be the minimum speed to be given? What must be the minimum velocity to be given to this projectile so that it can reach the second sphere, surface of the second sphere, right? So here we need to consider the gravitational pull of interaction. we need to give such a speed to this projectile so that it need not directly reach the surface of the second planet. It means, what I mean is, you should send the projectile with such a minimum sufficient velocity so that when it just reaches the gravitational field of the second planet, the second sphere should start attracting, should start doing the work on its own due to its own gravitational pull. It means, on this line joining the two centers, we have to find a neutral point, a null point. Null point is that point at which the force of attraction due to the first sphere just becomes equal and opposite to force of attraction due to second sphere. We have to find out the position of null point from the first sphere. So, send the projectile with that sufficient minimum speed so that if it just reaches this null point, remaining work will be done by second sphere by its attractive pull so that it can reach the surface of the second sphere. This is the very important point. We have to make use of the gravitational pull so we can save a lot of energy. So this is a very important principle. So we have to find out that null point. Null point is the point on the line joining these two spheres at which the forces are just becoming equal and opposite. The forces of pull are always opposite. At this point they will just become equal and opposite. Means the force due to first sphere will be just cancelled by the force due to second sphere. So the total force at this point becomes 0. So we will define that point. Here there is gravitational, attractive, interaction. Here there is gravitational, attractive interaction. Gravitational attractive interaction between the two spheres. N is the null point. Null point. N is the null point at which force due to first sphere, the force due to first spheres just cancels with the force due to second sphere. It means at that point the force due to first sphere is equal and opposite to force due to second sphere. So if you send this projectile with that minimum velocity so that the projectile reaches this null point, our purpose is served. Using this, the minimum speed v to be given to the projectile minimum speed to be given to the projectile should be such that the projectile should reach n, just it should reach n and its final velocity at n must become 0, such that the projectile should reach n final speed equal to 0. Final speed Vf must be equal to 0. With that thing in mind, we have to send the projectile so that once it reaches here, just with little more velocity, if it moves, the second sphere of 4 mass having greater pull than the first sphere will be able to attract that projectile towards the surface, towards the center of the second sphere. That is the purpose. The minimum speed to be given to the projectile should be such that the projectile should reach null point n with final speed v. Now let us first calculate null point n. N is that point at which forces cancel. The forces cancel each other. Now at this point, let us assume that this is at point distance ON. ON is the distance. Let us assume that this distance is given by small r. Let ON distance be equal to small r. That is the distance of null point from the center of first sphere. Then force of gravitation due to first sphere Gmm upon the distance from n is ON. ON is equal to r. This is the force of r square. Force of attraction, that is gravitational force at this point when the projectile reaches here, it will be 4 Gmm upon r square must be equal to the force of attraction by this second sphere is given by 4 times Gm, because mass of this second sphere is 4m. So G into 4m into m. So it becomes G into 4m into m, that is 4 times Gmm upon the distance from here to here. If it is r from here, then definitely this distance will be 6r minus r. From here to here, this becomes, because total distance is 6r, therefore from C to n, center of second sphere to the null point, it becomes Cn. Cn is equal to 6r minus r. So I can write 6r minus r square using Newton's law of gravitation. Now simplify. Gmm cancels with Gmm. So you are left with, on simplification, 6r minus r square. 6r minus r square is equal to r square into 4. It becomes 4r square. Taking square root on both sides. This implies 6r minus r is equal to 2r. Square root on both sides. There is another solution. When you take square root, you will get plus or minus 2r. So if you take minus 2r here, you will get another null point. That null point will be away from these two. That null point will be away from these two spheres, which will not be along the line joining the two centers. It becomes 6r on the other side. Therefore, we need not take that second solution. So we will take only positive 2r. If you take minus 2r, then solution will be minus 2r plus it becomes r is equal to 6r. 6r will be on the other side or on this side. So that will be of no use. It will be away from the line joining the two centers. So we want to find out null point along the line joining the two centers, in between the two centers. Okay. Therefore, r becomes equal to, if you simplify this, 2r plus 1r becomes 3r. So 3r is equal to 6r. Therefore, r is equal to 6r by 3. It becomes 2r. So r becomes equal to 2r. From here to here, already it is r. So from surface it becomes another r. So it is totally 2r. So if it is totally 2r from this, then from this one it is going to be 4r. From the Cn is going to be, Cn is thus going to be 4r, whereas On is going to be 2r. Okay. With this position, we can now calculate what is the energy to be supplied to this projectile so that it can just reach the null point. We are again using conservation of energy, conservation of mechanical energy. So if V is the minimum speed, V is the minimum speed to be given to the projectile so that it just reaches N. It just reaches N. Then total initial energy, total initial mechanical energy from the surface of first sphere, on the surface of first sphere, total initial mechanical energy from the surface or on the surface to be given to the projectile. So it is given by EI is equal to Ki plus Ui. Ki plus Ui. Kinetic energy plus potential energy. Initial kinetic energy plus initial potential energy. So therefore I write initial kinetic energy half mv square, where I have assumed v to be the minimum speed, plus initial potential energy. Here the potential energy on the surface of the first sphere is given by minus Gmm upon r. On the first sphere it is r. Then since there is a mutual attractive force exists between the two surfaces, we have to consider the potential energy due to the second sphere. So the term due to potential energy due to the second sphere is given by G into 4m, G into 4m upon m, 4mm divided by, if r is the distance from the first surface, r is the radius of the first surface, then from the second center, from the center of the second sphere, it is going to be 5r. Center of the second sphere is going to be 5r. If it is r here, from second sphere it is going to be 5r. The distance is going to be 5r, where OC is equal to 6r, right? Therefore, this second term is potential energy due to second sphere, 4mmg divided by 5r. I think you got the point. So this must be the total initial energy to be supplied to the projectile so that it can just reach the null point. Okay. Now, total final mechanical energy at n, when it reaches n, at n, when it reaches n, there final velocity Vf becomes equal to 0. Final velocity of the projectile becomes 0. So I write E at n, final mechanical energy at null point n is equal to kinetic energy at n plus potential energy at n. Since it is reaching with the final velocity f, vf equal to 0 at n, so kn becomes 0. 0 plus un. What is un? Un is potential energy at this null point. Look at this. This null point is 2r from here, right? And from the center of the second sphere it is 4r. Therefore, it will be purely potential. So I will write potential energy due to first sphere, that is minus. So plus, directly I can write minus, since potential energy is always negative, minus Gmm upon 2r due to the first sphere. Due to the second sphere at null point, it becomes minus 4Gmm upon this distance from the center to null point, Cn. Cn is 4r. Cn is 4r. So 4r, 4 cancels. So you can just write it as finally Gmm. You can take 4 cancels. So you are left with Gmm minus Gmm upon 2r minus Gmm upon r. So this is energy at null point. Now using conservation of mechanical energy. So this is first and call this as second. Conservation of mechanical energy implies conservation of mechanical energy using law of conservation of mechanical energy. EI must be equal to En. Initial energy with which it is projected must be equal to final energy at the null point. So equate this EI with En. So you are left with half mv square minus Gmm upon r minus 4Gmm upon 5r equal to these two terms, minus Gmm upon 2r minus Gmm upon r. So you can see here this cancels with this term. So you are left with only 1, 2, 3 terms. Using these 3 terms, we can find out what is the value of V, right? We want to find out the value of V. That will be the solution of the problem, right? Now, since m is common here, you can see small m is common throughout. So small m gets cancelled throughout. So you are left with half V square on the left hand side equal to, take this term to the right hand side. It becomes minus Gm upon 2r minus Gm upon 2r minus becomes plus 4Gm upon 5r. Now you can simplify this 4Gm upon 5r. If you simplify, Gm upon r is common. Gm upon r is common. So you are left with 4 by 5 minus 1 by 2. 4 by 5 minus 1 by 2. So 10 is the LCM. So 4, 5 2s are 2 5s are. So it becomes 8 minus 5. 8 minus 5 becomes 3. So it becomes 3 Gm upon 10r. 3 Gm upon 10r. Yes, correct. So 5r comes this side. Yes, 3 Gm upon 10r. 4 2s are 8. 8 minus 5 is 3. 3 divided by 10. So 3 Gm upon 10r. This becomes the equation for half V square, right? Now using this we can find out what is the value of v square. Therefore, I'll write 1 second here. Half v square is equal to 3 gm upon 10r. So v square is therefore equal to, take this to this right hand side, 3 gm upon 10r. So 2 ones are 2 5s are. So thus it becomes 3 gm upon 5r. So taking square root on both sides, we get therefore v is equal to square root of 3 gm upon 5r. Right? So this is how we get the result. By calculating the position of the null point, we can find out the minimum speed v. So 3 gm upon 5r under root is the minimum speed to be given to the projectile. So that v of or velocity at null point will be just becoming equal to 0. But when it becomes 0 at the null point, it doesn't mean that it's going to fall with 0 speed on the second sphere, because second sphere starts attracting with its greater gravitational pull on the projectile of mass m. So what will be its speed when it just touches the surface of second sphere? You can calculate yourself. Okay. So the distance of null point from the center of second sphere is 4r. From the surface it is 3r. So you can calculate with what speed final speed is going to fall on the surface of the second sphere can be calculated. Again you can note down the conservation of mechanical energy. Okay. So this is very important concept. This gives you an idea whenever a satellite has to be a rocket has to be launched from a planet to another planet, we need to consider the positions of these planets, their orbital positions, their speeds, actual speeds with which they are revolving around the sun, and we need to calculate that particular time at which the distance between the two planets is closer. The distance between the two planets must be closer. At that moment only one can plan to launch a rocket so that it can reach the other planet. Second thing is, we have to give that sufficient energy to the rocket so that when it comes into the gravitational field of the second planet should start pulling it towards its surface by its own gravity, so that minimum energy can be utilized. This is how the calculations are actually being done. Okay, you must have studied Mangalyaan. Successfully India has launched on surface of Mars, Mangalyaan. So please watch that movie, Mission Mangal. Very interesting. How much effort is being done by the scientists, the team of Indian ISRO scientists. Please watch that movie. I think you might have already seen. Again you can watch it so that you can study the motion of the satellites around the earth, how many times it revolves around the earth, how it, every time when it revolves around the earth, how it goes away from the earth and approaches the moon, and how it revolves around the moon and finally lands on the moon surface. It's really interesting. You will get excellent knowledge regarding the planetary motion as well as the satellite motion. Thank you. Have a nice day.